Hey guys, welcome to DSA-n-Design. Today we will look at how to delete a node in linked list at a given index, right? So let's try to understand what exactly the problem statement says. So how to delete a node at given index, all right, in linked list. All right, um, this is the problem statement, right, that we want to solve here, right? So let's try to understand what does it mean. So let's say I have a linked list. I have let's create couple of nodes here, right? Let's say I create 4 different nodes here, right? And this is basically n1, n2, n3, n4, all right? And then let's say this is at 1k. This is the address, right? 2k, 4k and 5k, all right? So this is the address of each of this node. Now what is the value? Let's put some value here, and what is the next basically, right? So next value, next, let's try to put some value, right? Next, basically what is the next, and then here is what, this is basically value and next. All right guys, so the value is, let's say, 10, and what is the next for this particular next is basically it's pointing to this particular node n2, and what is the address of n2? It's basically 2k. Then in this case here, let's say 20 is value, and the next is 4k, right? This is what it is pointing, right? And now n3 is basically having, let's say, 30 value, and it is pointing to 5k, right? This is pointing to this particular 5k, all right? And this is, let's say, 40k, and now this is actually pointing to null because there is no further node pointing. This n4 is not pointing to any further node, right? Now this is, let's say, my linked list. Now what I want to do, I want to actually delete a node at index number, for example, index number 2, all right? So let's see which one is index number 2. So this particular node 1, 0, 1, 2 and 3. So I'm saying I want to delete a node at index number 2, which means I want to actually delete this particular node, all right? Which means my this node n2, which is actually at index number 1, will be pointing to n4, which means my resultant, like after deletion, my linked list will be looking like this, something like this. So 1, 2, 3, right? This is n1, n2 and n4, right? If you look at it, my final linked list after deleting I mean deleting the node at index number 2 will be looking like something like this, right? Which means what should happen basically? So let's say in this case value next will be this will not be impacted, this will be still 2k, right? Here next will be impacted, right? Value equal to, let's say, 20, here it's 10. Now if you see this, this is going to point to n4, which is, what is the address of n4? It's basically going to be 5k basically, right? And here next for n4 is going to be same, it's not going to be impacted, right? Currently, right? This is how it is going to be this is how going to be looked like after the deletion, right? So hope you understand this concept, right? Now how we can do, right, the approach, basically this is my outcome, right? I want to do this, but how exactly, what exactly, okay, so let's try to, let me copy this entire thing, probably if I can copy, and then I can just explain here. No, I think it's not able to copy entire thing. Okay, that's fine, no worries. Let's try to let me use another different color pen, so I can actually just overwrite here. All right, so let's try understand here. So what I want to do basically, I want to delete this particular node. So how I can delete this particular node? That make sure I'm not pointing this, basically n2, this particular node is directly pointing to this, right? So this is the way actually, if I can just put a pointer directly to n4, then this is automatically removed, isn't it? Because this node will be orphan, then there is no further, I mean, this is not being pointed by any node, right? And then this is how we can actually do it, right? So this is the best way to do it, right? So let's try to understand how we can do in programmatically, right? So for example, now if I say this is my n2, right? So currently what is there? N2 dot next, sorry, N2 dot next equal to what? N2 dot next, okay, let me just write it properly. Okay, before the change, right? So what is this? N2 dot next equal to what, guys? It is actually saying N2 dot next equal to what? It's 4k, right? What I want to do is 4k is what? Basically N3, isn't it? This is the one. Now if I say N2 dot next equal to 5k, if I want to make it, then I have to say N4, isn't it? Now, how, if I am here, let's say I am at the node this, how can I say N4? How can I point N4, right? There is no way because I have to traverse it, right? So what I can do is basically, I can do something like this, N2 dot next. Instead of saying this, I can say N2 dot next dot next, isn't it? Because see, N2 is here, let's say, right? This is N2. N2 dot next is this, and after this, next to this particular node is this, right? So that's why I can say N2 dot next is actually pointing to 5k, means node number 4. This is how we can do it, right? Hope you understand this concept, right? So if you are at the head node, you can actually traverse the whole list by saying just next, 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 right? For example, if I am here, let's say I am at n1, right? In this case, for example, let's say I am at n1, and this is I know the address of n1, right? N1 here, right? If I want to actually go to n4, what I can do? I can say n1 dot next. The moment I say n1 dot next, I actually reached here. Then I say next again, I will reach here. So n1 dot next actually pointing to n4, right? This is actually n4, right? This is how actually you can traverse the entire linked list, right? So this is how you can actually directly point to this node, and then you can actually remove this particular node. Now what if another edge case, right? So for example, let me take another color for this to understand this particular scenario. So for example, let's say I want to delete at a node at index number 0, right? At index number 0 here. So this is very simple, guys, right? I just want to remove, and this is also a head node, right? In my given problem, this is head node basically. So can I say that I just want to delete this? No, I can just move my head by next, then I'll reach here. So can I say I can just ignore this, no? So what I can do, I can actually say head dot next. Okay, head dot next. I will make this head dot next as my head. Okay, means my head actually will be moving here. Problem solved. My head is now here, and this is automatically gone, right? So that's how I can say head equal to head dot next, which means I removed this already, and I will say return head, right? So in this problem, what I'm also doing is basically at the end, given linked list and return, yeah. After that, I have to return head also, head of the linked list, right? This is what my full problem is, right? All right, so let's try to start coding how we can do it, right? So what we have done last session, we have tried to add it, right? Similar, some of the code we will be using from previous one, but let's try to understand how we can do it. So let's create a new function, right? Our method public static what you want to say, I want to return node, means I want to return a head node. Then I'll say delete node, maybe I can say at, okay, something like that. Okay, delete node at, maybe all right, I'll say I'm giving actually two information here. One is head node, obviously I have to give where I'm going to start, and second one I'm going to say index, at which index I'm going to delete, right, the node at. So now what we will do is we'll try to actually see the edge case first, right? So if my idx equal to 0, which means I want to delete at first node, I mean the 0th index, right? Then what I discussed, I will say head equal to head dot next, right? Which means I am actually going to head dot next, means next node to the head, actually next node, and I am storing in head. So my head actually pointing to now next node, right? Which is basically I'll say return head. This is my edge case. This is sorted out. Now what I will say, when another case is when I want to have other index, anything other than 0th index I want to delete, right? So what I will do is I will just say I'll store the head node in a temp variable. So let's say I say t a temp maybe, right? Temp equal to head, right? Now I will traverse basically, right? I will traverse up to the just one node before that, right? How we actually traversed here. So we can actually pretty much use this particular code actually, what we did here. Or let me just try to write the fresh code, right? Int I equal to 1, and I want to traverse up to one lesser than index, right? So up to that location I want to actually traverse. Now I will say temp equal to temp dot next, right? This is what I want to do. One second, what is happening? Int no, this is not, no, this is node actually, right? This is not. So I think it's okay now. Okay, once I reach there, right, in this case here, in this case, one second, let me just try to show you here. So I want to delete this particular node, right? Index number 2 and 3, no? So I want to reach here, and then from here I want to just point to this particular next node. After, I mean, just skip this node and I'll go to the next node. How we can do is like n2 dot next, and I'll store that into n2 dot next, right? So this is how we can say here. After this, I reach there one node before. I'll say temp dot next equal to temp dot next dot next. Make sense? The moment I am done, my head is not going to change in this case because my head is still the same only, right? And then after that say return head. Okay, in this case my head was changed because I actually deleted at the head only. I deleted the node at the head, which was actually 0th index, right? In this case my head is still same. I'm not going to change anything, so simply I'm returning head, right? This is what we can do, guys, right? Let's try to see how it works, right? Let's try to create a linked list. This is already there actually. I don't want to do anything here. What I just want to do is I want to actually I just want to delete here instead of add, no? I want to just say delete head and index. I'll put it. Maybe I'll put index number 2, maybe. Yeah. Now index number 2, when I say this is 0, 1, 2. So ideally 10, 20, 30, 40. Before that, it should be basically 10, 20, 30, 40, 50. And after deletion, it should actually show me what? It should actually show me 10, 20, 40, and 50. Let's try to run and see whether it is working fine, right? Okay, let me running it. Okay. So, all right. Okay, something went wrong. What is that? After deletion. After deletion. Okay, after deletion. All right. Now this is done. All right. So, no, this is actually print pointing something else. Let me try to go here and try to current file. Now let's see what happens. It's pointing to something else, guys. Oh, this is perfect now. After deletion, no? After delete. All right. Deletion. Okay. So let's run it. I think we'll see very clearly here. So, oh, okay. I missed this semicolon here. Close it. Okay. Now if you see it, yeah. So the linked list before new node, or maybe it's deletion anyways. So before that, 10, 20, 30, 40, 50, and after that 10, 20, and 30 we removed it. Why? Because that was actually falling on the index number 2, and we actually wanted to delete index number 2. Now, can I just run one more thing? Can I try to delete the what is how many index are there? 1, 2, 3, 4, 5. Right? Oh no, no, sorry. 0, 1, 2, 3, 4. Can I say 4? Then I should be actually deleting 50 actually in this list, right? So let's see if this is working. You see, 50 is deleted. 50 was there before, and after that 50 is not there. Now can I just try 0th index whether this is working? This is edge case, right? Let's try to see this. See, 10 is gone actually, 20, 30, 40, 50. So this is how it is actually. You can actually delete a node at a given index, right? And this code is actually, if you know the previous, know how previous, if you can watch the previous video and you know how to traverse it, right? So we are simply just traversing one node before, and then from there we are pointing to the next node, right? That's how it is. So that's all for this video, guys. I'll see you with the next video, and this is going to be very interesting series. I'm going to cover each and every aspect about linked list, including the problem solving, right? That we also will be also solving a lot of problems in the linked list going forward, right? Right now we are just building the basic operation. We are just trying to understand the basic operations. Going forward, we will be taking up the problem in the linked list and will be solving them, right? So that's all for this video. I hope that this is kind of adding to some of adding some value to your knowledge base, right? And one request, please share this with your friends and subscribe if you are first time visiting here, and also hit the bell notification so you get the notification once I upload new videos, right? So this is going to be very regular series where you can actually keep watching, right? And that's all for this video. Thanks for watching, and I'll see you soon with the next video. Bye. Thank you.